Welcome to the Denford Orac tutorial. This is tutorial number 1, and we'll just demonstrate the entering of a program to operate in CNC mode. The screen you see in front of you is as you should see when you power up the machine. You may see a difference in the number of choices available. This is one of the later models, and it has a graphic simulation as well as the other 7 functions. We'll just scan along the console first to see what other keys are on there. You can see that there's a data input section, which is just a numeral pad with a few other features on it. Double arrows up, double arrows down, page insert and page remove. You then move over to the function keypad, which at the top left is GOO and GO1, and the bottom left is G90, G91, so that's for absolute or for incremental programming. G70, G71, second up on the left, is for inch or for metric programming, and G50, bottom second left, G50 is the datum entering function. You'll also see there that you've got MO2, MO5 and MO3. MO3 is spindle start command, MO5 spindle stop command, and MO2 is program end. You then move over to the manual keypad. You see at the top of the screen you've got manual, you've got start and you've got stop. In the centre you've got a hand control, so that these cursor arrows can be used when you're in manual mode to manually move the tool holder in X and Z axes. This is to move the tool into the work, and obviously this comes out, and this is the Z function key, the minus key, negative key, that takes the tool towards the chuck. Also here you have a plus and a minus key, which are feed rate overrides, so that if you want to reduce the feed rate during the program, you can use, or increase it, you could use either of these keys, whichever you wanted to do. This keypad is also used when you execute the program, but I'll show you that as we get to it. Further towards the end you come to the spindle control keypad. You've got a green and a red, obviously start and stop spindle, and the same here, you've got a spindle speed adjustment with positive and negative, so that you can increase or decrease the speed of the spindle during the program running cycle. Or if you're in the manual mode, you can obviously use it at that point also. And to the right of that you've got the stop switch, which is a lock off switch. Push it in and it locks it off, twist and it releases and it comes out. Enough said. Useful in an emergency, but if you do use it whilst you're running a program, it will stop the program and it will return to a manual operation when you reset, and you'll have lost your place in the program. So it would be necessary to manually move the turret to the correct position. Going on beyond that, there's a small cassette disc. That's an LDB 4401 small audio disc. That's used for storing programs and also storing tool offsets. So Because I've operated the stop button, we'll go back to the screen and you'll see what's happened. We've gone into a manual mode. And you can see that both X and Z axes are set at 0. So this is the point at which you could manually start the spindle and operate the cursors so that you could face the end of a bar and take a trial cut to set the diameter. You'll notice in the bottom corner at the right it says fast feed. There's provision on the machine to change that to a slow feed. That's by pressing the hand control once. It brings it to a slow feed. You press it once more and it goes to a step feed. And the step feed will be 0.01 millimeter each time you press the button. Now, because I've already set the tool cutting point up to be in line with the end of the face bar and at the set diameter, we don't need to do any of the manual cutting. So we need to get into the CNC programming mode. To do that, we move over. There are two ways that you can do it. You can go to the end of the machine and follow the reset button down and press the reset button underneath just once. That will take you back to the original display with the 8 choices. Or, simpler than that, you can go to the stop button that's on the manual control keypad, press it once, you heard it click, and that's taken us back to the program entering position. Now we'll enter a program here, then execute it so that you can understand exactly what's going on. You can see the choices: load, store, load, transmit. Enter new program is number 5. So we enter 5 on the keypad and press the E for enter. You see then that the screen changes to page 01. But the first command, first G code that this Orac requires is G70 or G71. G70 is okay if you want to remain in inch units, but if you want to go to metric units, you press the button again and you go into G71. So we're quite happy with that. So we press the double downward pointing arrows. That scrolls us down into page 2. Now the second G code that the Orac needs is G90 or G91. So we press G9091 button and it comes up as G91 incremental format. If you press it again, you'll go to absolute format. For this program, I'm going to go in incremental format. So I press the button again and that's where we go to. So page 2 we're happy with. Press the double pointing down arrows to scroll into page 3. At page 3 we need to enter a datum, which is G50. Now we know that we're going to use incremental mode, and we know that we've got the tool set on the corner of the faced and turned part. So the actual datum points are going to be X equals 0 and Z equals 0. So we need to do nothing further with that. Press the double downward facing keys and we'll go to the next page. We will use now a spindle start, which is M03. So page 4 is the starting the spindle. We're happy with that? Press the double downward facing keys to go to page 5. Now this, I'm going to do a small cycle program here to reduce the diameter of the chuck part by 5 millimeters, which means we need to take off a 2.5 cut, but we'll do that in 5 increments. And we'll also like to put on a finish cut. So the first line we'll use will be to move the tool slightly off the work, which will be the allowance for the final cut. So it's going to be a G00 or a G01. So X, we would need to bring the tool away from the work, so that's a positive, so it will be 0.05, enter. Z, we'll take that away from the end of the workpiece slightly, so that when it's running through the cycle it has a slight chance and doesn't go straight into the workpiece, so we'll take that away from the end, 0.5 millimeters also. We'll use the same feed rate here as we're going to use for the rest of the program, which is 100 millimeters per minute. We're going to use tool number 1, and the spindle speed we'll select 1500 and press E for enter after each of those inputs. So I'm happy with that page. We're going to move the tool off the work in the x-axis 0.05 millimeter, and we're going to move it away from the end, the faced end of the work, by 0.50 towards the tailstock. Press the double downward facing arrows, we get another key. Now, because we want to do 5 small cuts, we're going to use what's termed a do loop, and the G code for a do loop is G73. So I've entered G73. Now you can see it's asking, it's got a count and the cursor is flashing. It's asking us how many times, how many loops we want to use. We're going to use 5 loops here. Next command will be to move the X in towards the job by the depth of cut that we wish to take. So it's going to be a G00, and we want to go minus 0.50. Z we want to remain as it is, so that's a 0, enter. Although these feed rate, tool number and spindle speed are global, because we're in the do loop, I will enter them again to ensure that we have the correct speeds in. Tool number 1, what were we, 1500 I think. So we've now taken the tool in towards the work, 0.50, which is the depth of cut. The feed rate is going to go in at 100, the tool number 1, and spindle speed 1500. So we can press the double downward facing arrows again, go to page 8. It's a 0,1 this function. X, we want the tool to remain at the same depth, we don't want a tapered cut. Now Z, we want to reduce the end of this workpiece for 10 millimeters in length. We've moved away from the end 0.5, so we need to enter a 10.5 millimeter traverse towards the chuck, which is minus 10.50. The feed rate we've set at 100 on the previous, the tool number and the spindle speed also, so that they will be global and they will now follow this through this cycle. So we've gone up towards the chuck, 10.5. We now need another G command. We want to bring the tool away off the workpiece before moving it back. So we'll say X 0.50, we'll say Z 0 and edit. The feed rate here can be increased now because it's not going to be a cutting cycle. It's tool number 1, so that's global. Go to the next page, G01 again. X remains 0.5 off the work, so we enter 0. Now Z, we want to return 10.5 millimeters, so it's 10.50. It's a positive move because we're going back towards the tailstock with the tool. The feed rate will be global, which will be 1200, which was the same as the last entry, so we can go to the next page. Page 11, it's going to be another G001. So X, we now want X to go in towards the chuck, 0.5, so it's a minus 0.50. Z, we want to remain as it is, in the position it is, and the feed rate will be 1200 as it was before. So that's the little loop completed. We've put a cut on, we did the cut, we moved away from the job, we've returned back to where we started the cut in the Z axis, and we've moved the tool back in to the point, to the depth that the tool has just cut to. So this is now the end of that loop. So we need another page, so press the double downward facing arrows, and we now need to enter G06. End of loop, G06. Can't be clearer than that. Each time it gets to that, it will revert back to the first line of the loop until it's done the 5 countdown. So we now need another page. What we want to do now is do the final cut. So we'll enter GO. Now X, we've got to take that in the 0.05 and Z 0. The reason we've taken that 0.05 in is if you remember at the start of the program, I think it was line 5, we moved the tool off the job by 0.05 and away off the face by 0.50. So this is now getting that 0.05 back into the cut, which will give us a total cut depth of 2.5 millimeters on radius, 5 millimeters on diameter. The feed rate for this movement in, I will set this here now at the finish speed. We'll leave the tool number 1 exactly as it is. So X is now going to, the tool is now going to go into 0.05. New page. X, we need to remain the tool the same depth as it is, so it's 0. And Z, we want to go minus 10.50. The feed rate will be 60, which was what was set on the first move of this finish cycle. So we go to the next page. Now this, remember now that we've gone to 10.5 millimeter cut, we now want to face out 2.5. So 2.550 and Z 0, and the feed rate can still remain at 60. So that's now facing the parts that are being turned. So it'll come out and it'll be at start diameter. Feed rate will be at 60, so press the downward double arrows. We now need to bring the tool back to the starting position. So X is 0. And Z will be 10 millimeters. And that will leave it flush with the faced end of the work. The feed rate can be greater, be 1200. Because it's moving back, it's not cutting, it can come back in a hurry. So we've now got the tool back in the same position as it started the program. So we now need another line. We need to stop the spindle, which is M05. Another page with the double arrows. MO2. Tell it the program is finished. So that's that program entered and complete. So we'll press F1 to quit. There aren't any program errors. Now that's quite straightforward, the entry. We should run the program through, I think, but we'll do that in the next video. Any questions? Just ask. Thanks for watching.